So this is finishing up 3.4. This video should not be very long because as you look at the factored form in this problem, you can actually factor the denominator to be x plus 2, x plus 4. So where's the vertical asymptote? Is at x equals negative 4. Why? It's a non-canceling in the denominator. By the way, you can do some of these graphs while you're doing, like jump to the bottom and give you a vertical asymptote there, and negative 4. What else do we have? What about the holes? Well, as you figure out that x plus 2 cancels, there's a hole at that ordered pair of negative 2. Well, when you plug in, don't forget there's an implied 1 in the numerator. Negative 2 plus 4 would give you 2, so we're looking at 1/2. And it's the canceling factor. You don't have to say in the denominator or numerator, because if it cancels, it has to be in both. What about the horizontal asymptote? Well, it's bigger on bottom. Bigger on bottom, that's your Bobo rule, y equals 0. You know, and right now, for pre-calculus, I'm fine if you write out Bobo for your reason. This is not going to work for calculus, but for right now, it's fine. So the zeros in the function, well, let's put it this way. If the horizontal asymptote's at y equals 0, where is it going to cross the x-axis? Well, simple answer is it's not. At least for our purposes, we're not going to cross the horizontal asymptote. So we have a horizontal asymptote. Another way you can think of this is setting the numerator equal to 0. Let me do this in green. When does 1 ever equal 0? Well, it never does. So there is none. And one of the showing your work could either be referencing the horizontal asymptote is on the x-axis, so it's not crossing the x-axis, or this work up here, as I mentioned. I'm good either way. What else do we have? Negative 2, 1/2. Negative 2, 1/2. So how can we graph this then? Well, we can identify where it crosses the x, where it crosses the y-axis by plugging in zeros for x. And when you plug in zeros for x, you'll get 2 divided by 8, or 1/4. So it's definitely on this side of this rational function. And again, a better teacher would ask you to do 8 points. And I forgot what they named this function. I mean, g of x. Yeah. So what they're talking about is pick values for x. And if you're allowed to use a graphing calculator, you can use this as well. And if you're doing 4 on each side, you know, you can pick like -8, -7, -6, -5. And then on this side, on the right side of that branch, which is to the right of the vertical asymptote, don't do -2 because it's undefined there. -1, 0, and 1, things like that. And one time when I taught this, I actually just had students pick one value to the left. Like I think we would have done just like -5. So if you plugged in -5 into this problem, and you can just do the simplified version. So -5 plus 4 gives you -1. So 1 divided by -1, you would have gotten a value that's right here. And then so what we did is we were just trying to see, are we above the horizontal asymptote or below? Because in my class, we're not going to cross that horizontal asymptote. You know, so this graph looks something like this, where we get -5, -1. So we had only done 1 point. But for our purposes, I'm fine if you just give me the behavior. So rational functions look something like this. What I'll be grading is, are you on the right side of things? Do you have the correct hole? Do you have the correct y-intercept? Do you have the correct vertical asymptote? Do you have the correct horizontal asymptote? I don't need all of these points. I'll just put like, I don't need all this extra information. But I would be grading your domain still. So let me change colors and give you the domain. Those are your x values. So from negative infinity, that the first value where it's undefined is -4. That's your vertical asymptote until you get to -2, your horizontal asymptote. And then it's defined from -2 to infinity. Whereas your range, we're looking at the horizontal asymptote from the bottom to the top. And we also need to identify the y-coordinate of the hole, which we found out earlier to be 1/2. So from 0 to 1/2. And then 1/2 to infinity. And you should now be ready for your homework. I told you this would be a short video, so enjoy. Get busy on the assignment.